Hello, GED students. Welcome to Math 144 Club. This is the review class for you students who are right there on the edge. You just need that little extra push to get your GEDs. We are working on mixed math review for the GED test. Today, we're going to mix up all the data analysis on the test. So data analysis is a pretty broad topic. So good news, today's class is going to prepare you for 3 tests because as it turns out, data analysis isn't just on the math test. It's on the science and the social studies as well. Why is that? Well, data analysis is the math that scientists and social scientists use to make conclusions, to find patterns in the information that they collect. So we're going to be looking at that today. Super broad categories, but some of the things you should expect are mean, median, mode, range. We're going to see some of that. We're going to deal with some percentages and ratios. We are going to look at counting and probability. Bunch of great topics, kind of all over the place. Let's go see what we can do. Anytime it's going to be a day with a lot of challenge, I have to get you guys hyped up first. It's going to be a good day. Here we go. The table gives some important information about the planets in our solar system. What is the median length of day for the planets in the table? Okay, guys, what am I asking you to do or to find?
The median for the planets in the table.
Beautiful. We are looking for the median, and not just the median of anything. Thank you for being specific. We're looking for the median of the length of day for the planets in the table. One of the GED's favorite things to do is give you a table with way more information than you need. So help me to focus in, guys. Where should I be looking?
In the day column.
Yeah, Amy says in the length of day column. There we go. If we're finding the median of the length of day, there's the data we care about, the length of days. I don't want to look at mass or diameter of the planets or average distance from the sun. None of that's going to come into play. So this is my list of data and I want the median. And there's a couple common mistakes students make when looking for the median. But before we get into that, anybody know what the median is?
It's just what's in the middle.
Wonderful. Now I got a whole lot of students who listen to that definition, Stephen. They say, well, the middlemost number, they go looking at the list and they say, hey, this one's in the middle. And they feel pretty proud of themselves. So a little more specific, it is the middlemost number, but it's the middlemost number of what?
From least to greatest?
Sure, in an ordered set. You and I are saying the same thing in just 2 different ways. Stephen's telling me, put it in order, put it from least to greatest first. Yeah, you need to order your set before we can find the median. So let's go ahead and do that. Let's order this set. Now, as it turns out, it doesn't really matter if we do it from least to greatest or greatest to least, because the middle will be the same, but we still do need it in numerical order. So sure, Stephen, I'll go with your idea to do it from least to greatest. So what is the least number you see here?
9.9.
Beautiful. And then be really nice and neat about this. The most common mistake I see on median problems is people forgetting numbers. How awful would it be if you did all your math right and then just were a crappy secretary? Okay, so let's not lose any numbers. Next number I see.
10.7.
10.7 is the next largest. And we can see the skill of ordering decimals is coming into play here. What's next?
16.1.
And then you guys can just keep going. I'll
17.2, 24.0, 24.7, 2,802, 2,222.6.
Okay, sweet. And now, even with a list like this, a lot of students might struggle because I don't think the middle is totally clear. Do you guys see what I mean here? Which number's in the middle?
There's a trick to this. If I remember, like, if it's not evenly distributed, you have to, like, take the the most middle numbers. You add those and divide them by 2, correct?
Absolutely right. We're going to do what I call a mini mean. If you take one off the front, one off the back, and you keep doing that until you get to the middle of the list, and you actually have 2 in the middle, we're actually going to take, it's like a mini mean problem. You're going to add those 2 numbers together and divide by 2 so you can find their absolute perfect center. And good news is if you forget that, guess what? It's on the GED formula sheet. It's a little confusing the way they explain it, but it is on there. That's exactly what we're going to do. We're going to add together those 2 middle numbers and then make sure you press enter in your GED calculator after adding before you do the divide by 2, or you'll actually get a wrong answer because of the order of operations. So 17.2 plus 24.0, I'll press enter and then divide by 2, and I find the perfect center of that list is somewhere between 17.2 and 24. It's 20.6. If you want to cover this, this is in the data analysis unit of the crash course under the measures of central tendency. Jason's sock drawer contains 15 pairs of white tube socks, 10 pairs of black dress socks, and 5 pairs of snazzy Argyle socks. If Jason reaches into his drawer in the pitch black so as not to wake his sleeping wife and reaches in and pulls out a pair of socks at random, what is the likelihood that he pulls out a pair of snazzy Argyle socks? Dude, this is my life because Jason's my husband. He has a very organized sock drawer and he's not supposed to wake me in the morning. Okay. What are they asking me to do or to find?
They're asking you what is the likelihood that he'll pull out a pair of snazzy Argyle socks?
Interesting little question here. What is the likelihood? What does that mean?
Is that probability?
It is. That's probability. What is the likelihood? What is the chance? They're talking probability. Any thoughts on this?
Is it a good idea to like make a little notation of each thing, put them in?
Sure. I like it. What do you want me to make a note of, Stephen?
You just put them in, let me see, it doesn't matter what order, I guess. Just make like 15 pairs of white socks, 10 pair of black dress socks, then 5 pair of snazzy Argyle.
Yeah, Argyle are those ones with the diamonds on them. I don't know if you've seen them, but some people are super snazzy. I make bad sock jokes, Stephen. So 5 pairs of Argyle socks.
And they're expensive.
Good. Are they? I don't know. I don't buy Argyle socks. I just admire them on well-dressed men, okay? So there we go. Now what do you think?
We have to write as a fraction.
I like that. One of the ways that we can express probability is as a ratio, i.e. a fraction.
And 15 plus 10 plus 5, it will give us 30.
You want a total. I like what you're saying about fractions. I like what you were saying about total. And let me hear what Stephen was saying as well.
I was kind of going in the direction kind of where she was going. You have to get the total, 30 total socks out of
I
the total.
I love that language, out of. Good. Now you just brought together what Manal was saying with what Stephen was saying. That's glorious. The reason why we use a ratio or a fraction for probability is a fraction bar can be interpreted as out of. Absolutely. So if I'm looking at how many Argyle socks, I'm looking at how many Argyle socks are there?
5.
5. Out of, that's why everybody wanted the total. Out of how many total socks are in that drawer that he could possibly choose from?
30.
Beautiful. For those of you who aren't familiar with probability, I call this the wins. We've got 5 winning pairs of socks. If we're looking for Argyle, there's 5 Argyle pairs of socks, and there's the total. One way to deal with probability, a very simple way, is just to do a fraction of the wins out of the total. Very nice, you guys. So super excited. A lot of students would be so thrilled. They finished the problem. They remembered the wins out of total. They're so good at probability. They'd stop right here. And even though this is correct, it's not done. Anybody know what we still need to do? What did you say? Reducing, wonderful. All final fraction answers. I don't care if we're way back in 3rd grade looking at the fraction of the class, if we're in the land of science doing probability, if we're in the world of functions looking at slope, all final fraction answers should be reduced to lowest terms. Glorious. So you can do that in your TI calculator. It's really easy to reduce in your calculator, or you can do it by hand. So let's start by hand. Does anybody know how to reduce this by hand?
Divided by 5.
Beautiful. You look for a common factor. Both 5 and 30 are on the 5 times tables. Divide that 5 out of both of them, and I'm left with 1 out of 6. He's got a 1 out of 6 shot of reaching for those right socks in the dark. Now, if you wanted to do that on your GED calculator, let's say you're that person who's like, Kate, you told me you weren't going to teach me fractions because there wasn't enough time. And what am I supposed to do? I don't know how to reduce. Okay, this is how you do it in your calculator. You just type in the fraction by typing the 5. Then the N over D fraction button, and then the 30. And your calculator knows that all final fraction answers must be reduced, so that's all you have to do. Then press enter and your calculator will automatically reduce it for you. It knows. You guys don't want to give that a try if you don't know how to do fractions in your calculator. Make sure you can do it, because yeah, 5 out of 30 is easy to reduce, but if I gave you 26 over 51, you guys would be miserable. Okay, you see what I'm saying? Like, let's make sure we can reduce nasty ones too.
Will they have 5 over 30 in the answers?
No, not likely. Because those two things are equivalent. We're not that mean. I mean, the GED is tricky. The GED is not trying to see how much you have memorized. Like, they're trying to see your understanding of mathematical concepts. But because it's written by mathematicians, they're just going to have reduced answers because that's the norm. But they're not going to try to trick you to see if you know, like, the last final step is reduction and give you both. But they might give you something that looks really tempting and has a 30 in it. So you'd be tempted to go for it if you didn't reduce. So maybe they'd have 15 over 30 and then you'd start doubting yourself. Like, maybe I picked the wrong one. There's one with a 30 and I know I need a total. I know I need a 30. Do you see what I'm saying?
Yes. Okay. Thank you. Because
You're
I
welcome.
always wonder if they try to do that.
They do not usually put two equivalent answers. If two numbers are equivalent, they're technically both right, even if one is more normal than the other. They're asking wonderful questions because a lot of times students aren't sure what's right. They get really, really hung up on, but what's right? And I'm like, they're both right. 5 out of 30 and 1 out of 6 is the exact same answer. They're totally and completely equivalent. You know, and I could convert them into equivalent decimals or equivalent percents. And my students over there, but what's right? And I'm like, right. All right. Lots of forms are right. They're like, well, which one's it going to be? I can tell you which one's more normal. A reduced fraction is pretty dang normal. do you see what I'm saying?
Yes. And
Okay.
see, a lot of time I feel like you could just look to the answers to kind of figure out, like if it's a percentage, they want to obviously.
Amy, that's brilliant. I didn't give you answers here, so we just rolled with what Stephen and Manal were saying, which was let's do a fraction, and that is the easiest one to do this. But if it was on the GED and there was no specification, you would definitely have multiple choice that would give you a clue. Should I have a decimal? Should I have a percent? Should I have a fraction? And yeah, they would not have two equivalent answers because right is right is right. You want to know what's the problem with math class? It's never the average student who's talking up. You know who speaks up? The math whiz. The math whiz knows all the answers. He speaks up. Then all my average students stay silent because they're like, oh crap, everybody gets it, not me. And then 95% of the class is confused. The one math whiz feels pretty proud of himself because he's so smart and everybody else hates math. Okay, so I need my average students to ask those questions. So yeah, this is data analysis, and these probability problems show up on science a lot, but they also show up on math. So make sure you understand this concept, you guys. And it'll be just like the GED to pair this with tables, charts, and graphs. So yeah, we did a straight word problem, but we could have had our data in a graph of some kind. Ooh, speaking of graphs, Rich's Restaurant reports its annual expenses and profit two ways, in a table and in a circle graph. The table below represents their 2015 expenses and profits. Which circle graph models the same data? All right, what am I asking you to do or to find?
Which circle is this, the same table, the table one?
Absolutely. So which circle graph is giving the same information as the table? Now, obviously, the tables and the graphs look a lot different, but we have different ways to visualize or to organize the same data. So can we find the ones that match? There is not one right way to do this problem. So I really want to latch onto what you guys are thinking, because I won't be there on test day to show you the normal way mathematicians usually do it. So any thoughts? What are you thinking?
Look for the highest and the lowest, maybe?
Sure. We could examine the highest and the lowest. What are you looking at? Are you looking at the table first or the graphs?
I was looking at the table.
Cool. Which numbers are standing out to you as the highest and the lowest that you want to pinpoint on?
Gross sales.
Does anybody know what gross sales means?
That's why I can't find it in the circles. So what's the name of this one? No, I don't know.
Yeah, you're not going to find gross sales on the circles because gross sales are not a portion. Gross sales are the total. If you're talking about the whole thing, even look at how it says expenses as a percent of gross sales. Gross sales is like the total number. Yeah, that is a vocab word for the math test you need to know. This is not the only instance where it might come up. Gross. So literally the word gross, I know in common English now it means like disgusting or ew, but it originally meant fat, which I find kind of personally offensive, you guys. I don't think fat is gross. But anyway, literally that's where that word comes from. It's the fat. It's before you remove anything. It's that big total amount.
So the total wouldn't be included,
exactly. Right? The total is the entire graph. It's not a slice. So then let's focus in on what would be the biggest slice of the pie. So the biggest slice then would be our food costs. So yeah, that's a great thing to do. We could cross off any graphs that don't have a big food cost slice, huh?
The first and the second, huh?
The first and the second, yeah. It's pretty big here, but it's not quite as big as other employment expenses, so I'll take it out here. And then food cost is really small here. They've never obviously run a restaurant. So now I've got it down to 2 with really big food costs. I didn't use any math. I didn't use percents. I used Stephen's common sense. Nice, and I've got it already narrowed down to 2. Any other thoughts?
I think we have to go to the smallest.
Well, you know, the thing is, we've got 2 circle graphs to compare. It would be wise of us to go to where they're different. Because if we're looking at a bunch of places, they're the same, it won't help us too much. So like when I look at wages and salaries,
It's the same.
they look about the same. And profit margin looks about the same. Can you hone in on an area of this graph that looks different?
I would say marketing and overhead.
Okay, marketing here as compared to marketing there.
Yeah, because marketing is larger than overhead on the first one, and it's smaller than overhead on the second.
Ooh, so you want to compare. So in this one, you're saying marketing is larger, and in this one, you're saying overhead is larger. Okay, so which one of those two statements are true?
So the last one's true.
Okay, so we should have overhead. She's saying overhead should be larger than marketing. Oh, I agree. It's almost twice as big. Beautiful. I love that reasoning. This is the right. Now, you might have focused in on a different piece than Amy. That doesn't mean you would have been wrong. You know what I'm saying? And if we'd have gone through each one, Manal, we would have gotten there eventually. I was just thinking, oh my gosh, some of these are the same. Let's go straight to the ones that are different. So when you have similar answers, hone in on the slight differences. And this isn't only true in math. This is also very true in the reading comprehension questions on the other subjects. Two answers are really similar. Really hone in on what's different about these two. And then which of those two differences is better.
Go, Amy.
Well, I liked both of you guys' logic, because guess what? If I was teaching this to you in a class, this is not what we would have done. We would have picked up our calculator, we would have found percents, we would have created circle graphs, we would have done a lot of work, and you guys didn't need any of that. You guys just used some common sense and some reasoning skills, which I think is brilliant. We need those strong test-taking skills when we go to take the test. So nice job, everybody. I'm impressed. When I'm looking at questions like this, because I'm not a visual person, if you guys sat next to me in a test-taking room, you'd laugh, because I have my fingers in my ears and I'm like muttering to myself, trying to notice the differences because I'm not a really observant person. That skill of just like looking really hard at something can be very challenging. This is the topic of data analysis. This is from the Interpreting Circle Graphs class. Lucero and Francesca are lab partners. They have been working on a lab where they measure the starting and ending temperature of a liter of water after a certain chemical is added. They spilled something in their lab notebook and cannot read the final temperature for sample 6. However, they do have in their notes that the mean final temperature was 24 degrees. What was the final temperature of sample 6? Okay, this one might look super familiar to you guys because this is so similar to something that actually appears on the GED. I only know that because students send me questions all the time, right? So all these students take either, I don't know if it's on the real GED or if it's on the practice test, but they take it, they must be seeing something like this, because I get sent this kind of question probably, a dozen times a year. So definitely this is typical of what you're gonna see. So what are they asking me to do or to find?
The temperature of sample 6.
Absolutely. This missing piece of data here. Interesting. And it would look like, how in the world am I supposed to know? So we're gonna have to find out, what do we know that can help us find the temperature of sample 6? Any ideas?
We have to add the numbers of final temperature and divide it by...
Tell me why you want to do that. What is making you want to do that particular methodology? What are you seeing in the problem?
Because in their notes that the mean final temperature was 24 degrees.
Manal saw the word mean, and her first instinct when she saw the word mean was to go find the mean. But here it's interesting because we already know the mean. The mean is 24 degrees, and we're trying to kind of work backwards and finding a missing number. Now, I agree with you, Manal, that I could do that, add and then divide, if I did the guess and check method. So just pick a number and let's check it. So 16 plus 18. And why are we doing this? Because the process to find the mean is total all the items in the data set. So we're adding them up, we're totaling them, and then divide by the number of items. So I'm going to put in that mysterious 24 to check if it's the right answer. Press enter, and now divide by, what should I divide by, Manal?
7.
1, 2, 3, 4, 5, 6, 7. Brilliant. 7 items in the data set. And that gives me something close to 24, but it gave me 23.428, yada, 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 yada. Because this is not an exact answer, I would have to keep going to see if anything else gets me closer. Okay, shall we try the next one?
My concern is, what if they didn't tell you the final temperature was 24?
They'd have to tell you the mean temperature. You'd have to know something in order to work backwards.
They'll give you that.
So either they're going to give you all the data and you're working forwards to find the mean, or they'll give you the mean and you're working backwards to find a piece of data.
In this case, we're working backwards.
We are. We know what we think of as the answer. Because Manal knows, I know how to find mean, add and divide. But the problem is we already knew the mean and we needed to work backwards. Okay, so one way to do it is the guess and check method. So that's what we're using. It's not the only way.
Yeah, that was my instinct also, was to just plug in the numbers.
Okay, wonderful. So let's try the next one then. Let's try 26. So I'm going to do it again, but instead of using a 24 here, I'll use a 26 here. So 16 plus 18 plus 24 plus 25 plus 29 plus 26 plus 28. That one gives me 166, and if I divide that by 7, ooh, I'm getting closer. It gave me 23.71, looking better than the last one, but it's still not perfectly 24. What do you think it is?
D.
D, let's try D.
Give us 24.2.
Okay, 16 plus 18 plus 24 plus 25 plus 29 plus, she wants to try 30. Okay, so plus 30 plus 28 gives me 170, dividing that by 7, 24.28. It's about as close to 24 as the other one is on the other side. So I'm thinking it's got to probably be C then, you guys. So let me just check C. Isn't that funny? Always the last one we try. So this time I'm going to test it with using 28 here. So plus 28 again, and now divide by 7. Woohoo! Perfectly.
So it's not
24.
necessary to take the nearest one. We have to take exactly the same one.
If they were all not quite 24, then I would look for the one that's nearest, because scientists do round a lot. Like if your average was 23.9877, you might round it to 24. So it would be possible to have one that's not perfect, Manal. But if that was the case, I would want to make sure I did all 4 and pick the one that was closest. So this is what I'm going to tell you. No GED teacher would teach a guess and check method for this. We all know the right way to do it. Now, guys, don't get me wrong. Guess and check is not wrong. Okay. It's totally legit method, but we all know like the standard way to do it. So we just launch right into our standard explanation. But here's the deal. When you're going there and you're taking your test, you're not going to remember every standard way to do everything. You don't do math 10 hours a day like I do. So it's so important to use these wonderful reasoning skills like you did. So maybe you don't know the right way to do it. Okay, use what you do know. Use those lovely common sense tricks like you used on the last one. Topic here is data analysis. This is mean, median, mode, and range, but I should have put digging deeper because I actually teach this topic in 3 lessons because they can get so challenging on the GED. This is definitely one of the more challenging styles of problems where we're working backwards. Speaking of challenging, let's take a look. I'm trying to freak you out. Nobody get intimidated by my variables. Here we go. Matt belongs to the math club. He is writing a formula to represent the mean score of the math club members in a competition. If there are 5 members and he represents their points using the variables A, B, C, D, and E, which of the following expressions could be used to determine the mean of their scores? What are they asking me to do or to find? So which one of those expressions would give us the mean? Now, it's a little scary because they're algebraic expressions, but how do we find the mean, you guys?
We add and divide.
Wonderful. We total. And Manal, I never like to say add because sometimes in totaling there's adding and sometimes there's multiplying. Just depends how many items you have that are the same, okay? But yeah, adding generally is an easy way to find a total, just adding up the individual scores. And then we divide by the number of items in the data set. So I would say then just by listening to what Manal's saying, add and divide, 2 of these look really tempting. 2 of these look like decent answers. Yeah, Amy, you're nodding your head. Which 2 are you narrowing in on?
B and C.
B and C both have us adding and then dividing. Adding and then dividing. So B and C both look pretty tempting. I'm going to erase the other ones because they don't have us adding and dividing, so they don't make a lot of sense. But the difference between B and C is not a difference of data analysis, it's a difference of understanding the order of operations. One will give you a right answer and one will give you a wrong answer, because even though these both have adding and dividing, the way those 2 operations would happen are in a different order here. Anybody know which it has us adding first and then dividing?
I think it's C.
It is C, absolutely. We can use fractions to group things. When you have a fraction, we are supposed to do groupings like the top of this fraction before we do the implied division. This one has us adding and dividing. Whereas if we typed this into our calculator or wrote this expression, the order of operations says to divide before you add. if there's no grouping, we would have to do this division first and then add afterwards. And that would give us a wrong answer because it would put things in the wrong order. C is the correct answer. That's how a mathematician would write it, even though it makes students uncomfortable.
This was a tricky one.
And students love B because we assume math is going to go from left to right. We really do. We think math is going to be like reading. But as we know, the order of operations says we don't simplify from left to right. We simplify first groupings, and that's why the top of that fraction would have happened first. Then after that, any exponents. Well, there's no exponents in either of these. But then after that, any multiplication and division has to happen before addition and subtraction. So if you don't group your addition somehow, the division would happen first. Now, they chose to group their addition with a fraction bar. You could have also done it with parentheses. That would serve the same purpose. Does that make sense? Is anybody mad at me?
I mean, a tiny bit.
You're just mad at mathematics that it doesn't go from left to right, Amy?
Right? You have to remember this whole Gemma.
That's one of those things like solving equations that I need to be so second nature to you that you can do it without thinking about it. The order of operations and solving equations should be like driving a car to you, where you don't think about it anymore. Everything's an autopilot. You can be totally jammed out to the radio, talking to your mom on the cell phone, putting on your mascara and eating your banana. Okay, that is how I drive, so don't drive on the roads near me. But anyway, that's how I need you with the order of operations. Like, it's so second nature, you don't think Gemma anymore. So if you are that student who every single time you have an order of operations problem, you still have to think real hard about it, you have not practiced to the point of competence yet. Yeah. I need your muscle memory in math to be so good at Gemma, you can do it with your eyes closed. Do you hear what
I
I'm
have PEMDAS in my head, parentheses.
And that's a hard habit to break.
So it's like, yeah.
Let me just say there's nothing wrong with, I mean, PEMDAS is just, both of those things are memory tricks. You just have to know the 4 steps of the order of operations. I really don't care how you remember it. The only reason I reject PEMDAS is because some students interpret that as, oh, there's 6 steps. First, I do all the multiplying, then I do all the dividing. Then I do all the adding, then I do all the subtracting, which leads to common errors. This one should have been in the mean, median, mode, and range digging deeper lesson, because this is one of those more challenging GED style examples. Next one. A certain hamburger bar has a build your own burger bar. For $7.95, customers are allowed to choose one item from each of the categories below. Bun, meat, sauce, and premium topping. How many distinct burger combinations are possible when choosing one item from each category? And then we have these lovely categories of options and yummy, delicious, I love burgers, but what are they asking me to do or to find?
How many combinations are possible?
Burger combinations can you choose?
Lovely. So both Stephen and Amy, yes, we're finding how many distinct burger combinations are possible. Like if I pick one bun, one meat, one sauce, one topping. Any thoughts, guys?
I used to hate these. I don't know why.
Well, lots of teachers teach this different ways. So there's 3 typical ways taught for this, Stephen. One of them is with a really funky looking formula that involves exclamation points and makes students freak out because it looks so gross. I don't know if you've heard of the permutation and combination formulas. As it turns out, those formulas aren't as bad as they seem, but it scares students. The other way to do it that teachers will often teach is with this diagram that has like lines everywhere, and it gets really confusing. So that's also tricky for students to understand, but there is a simple way to do it as well. So I don't know which way you did it, but it might have just been that we presented it in a way that didn't click with you. The way that they do it with the lines is you start with your buns. So like I could do white, wheat, or gluten-free. There's 3 different options for buns, right? So even just, if you just change the bun, we're already talking about 3 types of hamburgers, but the buns aren't all we have to go on. Then we get to pick our burger type, right? We could do hamburger, turkey burger, veggie burger. We could do all of those 3 options on white. We could do all of those 3 options on wheat. We can do all of those 3 options on gluten-free. And already I've only considered 2 things and my diagram is getting real messy and I'm running out of space. I mean, this is complicated, but let's see what happened. We started with 3 original choices. And then when we got the next 3, hamburger, turkey burger, and veggie burger, look what ended up happening. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. When we considered the 3 buns and the 3 hamburgers, we got 3 times 3, 9 distinct options. And in fact, that's the quick, easy way to do this, Stephen. Instead of drawing out the diagram that will show you this visually, you can just multiply by your number of options. So how many options do I have for a bun? I have 3 options for a bun. Now I could put any one of those meats on any one of those buns. So I times it by my meat options. And you just keep progressing that way. Each time you're faced with a new option, you multiply by your number of choices. So let's look at our number of sauce choices. How many sauce choices do we have? 4 sauce options. Barbecue, ranch, ketchup, blue cheese dressing. Now I have 4 options. And now I got a lot of different burgers to make, but I'm not even done yet. We have some more options. How many topping options do we have?
We have 5.
We have 5, absolutely. You could do cheddar cheese, bacon, sauteed mushrooms, grilled jalapenos, or fried egg. 5 topping options. And you can see why I said if we tried to do this in a picture, a tree diagram as they call them, oh my dear Lord, it would be as messy as could be. No wonder Stephen would be confused. Way easier to just multiply by your number of choices here. Notice it's not adding, it's multiplying, because off of each one of those, like off of this hamburger option here, then I would bring off 4 more sauce options and 4 more and 4, and we just keep multiplying each time. Okay, so 3 times 4 times 5 gives us a whole lot of possible burger combinations, 180 distinct burger combinations.
That looks easier.
Yeah, it's way easier, but you have to remember to multiply. Students who forget this, and knowing what the visual looks like will help you to remember to multiply, okay? So it's not like the visual is useless, Stephen. It's just that the visual gets way confusing the more options I have. And so understanding that multiplication principle, not addition, will help you here. And probability and counting. So this is the concept of counting. We call this counting. Students are like, why do you need to teach me to count? I'm like, because you're used to going 1, 2, 3, 4, and I want to get to 180 really quickly, okay? So it would take you a really long time to write down each one of those combos. Imagine you trying to write out all 180 of them. So we need a fast way to count when we have situations like this. So that's why it's called counting. But that being said, the style of counting and probability problems on the GED are simple. It's not like geometry where they like to go deep. So just having these basic understanding of it can just really open up a lot of questions for you. The circle graph to the right shows biologists' estimates of what portion of Earth's species belong in each of the 5 kingdoms of living creatures. Scientists estimate that there are 8.7 million unique species of organisms on our planet. If their estimates are correct, approximately how many species of fungi are there on the Earth? All right, guys, what are they asking me to do or to find?
How many species of fungi are there on Earth?
Beautiful. We are looking for the number of species of fungi. Okay, any thoughts?
I think we have the total. It's 8.7 million.
We do have the total. That is 8.7 million.
We can multiply it with 6 divided by 100. We'll get the number.
Beautiful. Okay, so let me back up to what Manal's saying. Manal knows something about percents. She's saying if 6% of the total species are fungi, she knows how to translate that into a math statement. What Manal said was, I would do 6 out of 100. Manal knows that percent means the same as out of 100. So one way to think about 6% is the fraction 6 out of 100. Manal also obviously knows that of means to multiply. This really confuses students because we usually use it with ratios and proportions, and they feel like, oh my gosh, I shouldn't multiply. No, this is how you find a percent or a ratio of something. So you multiply. And then she wants to multiply that by the total species, 8.7 million. Lovely, sure, I could do that, Manal. What do you get?
522,000.
Interesting, because if I typed in 6 divided by 100, or 6 over 100, like you said, and then times it by 8.7, I would get this number, which is what most students get in their calculator. But yet Manal didn't say 0.522. Manal said 522,000. So I want to know how you got from there to there, Manal. You're right, but not a lot of students would see that connection. So what did you do?
I did the 8,700,000.
Wonderful. Okay, so I'm going to back up to there, okay? Manal knows that 8.7 million, if you want to get rid of the word million and just turn that into a straight number, all you're going to do is replace that decimal place with the comma. So this is easy to some students, and some students have never seen it done before, Manal, so that's why I just wanted to slow you down. So I'm just going to replace that decimal with the comma and then add enough zeros to make sure that is the millions comma. And some of us are really good at place value and some of us struggle. So I just want to make sure everybody's with me for the fact that that is the same as 8.7 million. Okay, wonderful. Now I'll get the same numbers, 5, 2, and 2, but they'll be in a very different decimal place. So 6 divided by 100 times 870000. And no, you don't need the commas in your calculator. And we can see how Manal got 522,000. So A is the correct answer. I don't think I've ever had 4 students so good with percents. That's impressive. I'm telling you, percents are such a sticking point for most students.
I used to struggle with percents at one point, but I practiced and I got a little better.
Stephen, can I just have you come speak in every one of my classes? Because I have heard that message from you over and over again. I used to struggle. I feel like that's your anthem. Stephen's like, I used to struggle, but then I used to struggle, but then because I got so many students in my classes who think you're either a math person or you're not a math person. And it's true that some of us catch on to math faster than others, but there's nobody I've ever met who, if they don't work on it, doesn't get over the struggle. And you're just such a good example of that, Stephen. I don't know how to do it. I don't know how to bottle up what you got and sprinkle it on my students, but I am just like, engage in the struggle, you guys. We can all do this.
You're inspirational, Stephen.
We need a Stephen t-shirt. It can have that cute Bitmoji picture, and then it could say, I used to struggle, but I ... I have a gentleman in my class, I won't name his name, and he started my GED class with such severe disabilities. He was told when he was in high school that he couldn't really do academics, so he should go to this special kind of school because he would never be college bound. And then he decided later in life he wanted to go to college, and his degree wasn't good enough, his high school degree, so he needed to come get his GED. He's been in my class 5 years, and that man is not afraid of a struggle. Everything that makes him struggle, he says, buckles down, I'm going to try harder. And now whenever new students start the class, they look at him and they look at him like, oh, this guy's really good at math. He's so good at math. But it has come, he won that. You know what I mean? He earned it. It did not come easy, but this man is just such a triumph of what persistence will do. And so anyway, that's how I feel about you too, Stephen. I think it's awesome. And you should get a trophy, a really big one. I'm tearing up just thinking about it. Y'all make me so proud. The unit is data analysis, but the topic here is interpreting circle graphs. Circle graphs are a visual representation of percents. They are interwoven, intertwined. So let's look at this one, a easy looking problem that would trick a lot of students. The record high temperature in Fairbanks, Alaska is 99 degrees Fahrenheit. The record low temperature is negative 66 degrees Fahrenheit. And guys, I can attest to this because I lived in Fairbanks for a year. By how many degrees does the temperature in Fairbanks range? Okay, what are they asking me to do or to find?
The change of temperature by how many degrees?
Lovely. Amy knows what range means. Range means the difference or change in temperature. The difference between the max and min, the high and low temperatures. Okay, so range is just generally the difference between the maximum and minimum items in a data set, but you know, that's all they told us. They told us the high temperature, that's the max, and the low temperature, the min. Beautiful. So I got so many students who do this wrong. So I'm just gonna show you what they do wrong. So we'll just get that out of the way because so many students go, okay, 99 degrees, I'm gonna subtract the 66 degrees, and they say the temperature in Fairbanks, Alaska only ranges 33 degrees. And I'm like, you're out of your mind. The temperature in Fairbanks, Alaska could range 33 degrees in an hour. Okay, that is such a small range. No way. Something went wrong. Anybody want to tell me what went wrong?
Well, first you have to go up 66 to get to 0.
It seems to me like you're picturing a thermometer. So let's do that.
Yes.
Amy's picturing a thermometer where there's 0, and if you're at negative 66, you're way down there. But if you're up 99, you're way up here. And she's like, whoa, the range or the difference between those two numbers is large. Amy said from here to here, you'd already have to go up 66 degrees. Okay, lovely. What else are you thinking, Amy?
And then you have to add the 99.
And then you'd have to add another 99. Oh, looks like those difference problems we were covering on the non-calculator section. 66, and she wants to add 99, giving me, what would that give me? 165 degree range, a huge range.
Fast.
Now, Amy did this visually, but shouldn't visually match what we said here? I have so many students who say, but Kate, but Kate, but Kate, but Kate. Difference means subtract. Amy shouldn't have added. Okay, well, let's do this with subtraction. It should work. Good math should always work, whether I'm using my math formulas or Amy's using her pictures. Our good reasoning should get us to the same place. So let's do this as a difference problem. When you're doing difference, you want to start with the high temperature. So the high temperature is 99 degrees. And then you want to subtract, right? Range is high minus low. We want to subtract the low temperature. Guys, what is the low temperature?
Negative 66.
Negative 66. Brilliant. Negative 66. Guys, I'm going to take 99 degrees and I'm going to subtract a negative. Okay, whether you do this in your calculator, negative 99 degrees minus negative 66, or you do this by hand, you're supposed to know that subtracting a negative is the same as addition because of that lovely picture Amy showed us. So yes, this is a subtraction problem. It's just you're supposed to know when you subtract a negative, the opposite of subtraction is addition, and it does end up adding in the end. So whether you use my formula, my step-by-steps your math teacher taught you, or Amy's diagram, we better end up in the same place or we broke math.
I see that where people can get that confused.
Sorry.
But it makes sense how Amy explained it.
I like the way Amy explained it because the visual helps us ground us down in reality so we don't make silly errors like the first student that I did in red. So I've actually found that my students in almost every area of math, they do worse with word problems, but negative numbers are an exception. Most students actually do better when they have the word problem context to make sense of negative numbers. Because like Amy did, they could draw a thermometer and figure it out that way rather than using the formulas. And that's because of that principle where when we just try to memorize rules, we mix them up. So students who just memorize the rules for adding, subtracting, multiplying, and dividing negatives often just mix them up and give me weird answers that don't make sense. So I actually like context with negative numbers. It helps us be able to just evaluate our answer. Like what if we did get it wrong and get 33 degrees? There should be alarm bells going off in our head like, no, look at those two temperatures. They are way further apart than just 33 degrees apart. So again, this is in the mean, median, mode range lesson, but it's in that digging deeper lesson where I give tricks like I'm pretty sure the GED is going to do. The owners of Firefly Bar and Grill are analyzing their 2019 sales in order to determine a marketing strategy for 2020. Based on the average sales per day in 2019, pictured on the bar graph to the right, they decide to close on Mondays to save on labor and operating expenses and to institute a happy hour on Tuesdays, Wednesdays, and Thursdays. They anticipate that happy hour will increase beverage sales by 50% on those days, which graph below could be used to forecast their 2020 average sales per day. You guys, when we do data analysis, you're going to see a ton of stuff about running restaurants because guess what? You know what I did before I was a math teacher? I was a chef. This was real life applications of all these lovely math concepts. I use these things all the time. These are the kind of skills I had to do. So what are they asking me to do or to find?
Which graph could be used to forecast their 2020 average sales per day?
Beautiful. Okay, so we're wanting to forecast what 2020 is going to look like. Any thoughts?
So would you look at the Tuesday, Wednesdays, and Thursdays on the graph?
Cool. What would you look for Tuesday, Wednesdays, and Thursdays?
The increase in sales?
Yeah, they said those beverage sales were going to increase by 50%. They expected on Tuesday, Wednesdays, and Thursdays. So we definitely want a graph where we see an increase in beverage sales by about 50% on Tuesday, Wednesdays, and Thursdays. What should we be looking for on these graphs if we're looking for those 2020 projected sales? So I'm wondering which one of these graphs, is there any I can rule out, or are there any that look like they do have that 50%?
The last one, rule out.
Lovely. In the last one, we do see an increase in sales, but it looks like it's an increase in the blue column. The blue column is food sales, whereas the Tuesday, Wednesday, and Thursday orange sales, the beverages look pretty similar. Yay, I'm going to rule that one out. Now, Tuesday, Wednesday, and Thursdays definitely got a little bigger on these graphs than they were originally. Those two are looking pretty good based on that statement. What else do we know about 2020 sales?
The first graph, I guess with this one we have to remove it.
What piece of the first graph do you not like?
It's closed on Mondays.
Beautiful. They said they're going to start closing on Mondays. How are they making sales if they're closed on Mondays? Glorious. This one is better, with no sales on Mondays. Nice job. Okie dokie. Well, this was a lot of graph reading skills and close reading skills as well. So we're looking at reading comprehension plus graphs here. And that's why when students say, what things should I study for the test? I'm like, it's not a list of things that you need to study. You've got to be a reader and you've got to be a reasoner. If you're not a close reader, you're going to get tricked by the GED over and over and over again. This is a really good example of GED style. And this is the topic of data analysis. Yes, this is frequency focused charts and graphs, but like we said, the skill I just got you guys on with reading. Let's move on. A recent study found that about 3 out of 5 students enrolled in college in the US are female. The freshman class at one college consists of 483 students. How many of those students are probably male? So you might say, what's this doing in data analysis? Guys, data, we got statistics, 3 out of every 5 students. This falls under that broad category. So what are they asking me to do or to find here?
How many of those students are male?
I want to know how many guys we're looking at here. Okay, I can think of at least 4 different ways to solve this problem. There is not one right way. So what are you guys thinking?
Immediately, I just see that the freshman class consists of 483 students.
When you talk about 483 students, is that the males, the females? What am I talking about?
Everybody.
That's everybody. Beautiful.
Yeah. And then it gives you that the recent study is that 3 out of 5 students.
Yeah, 3 out of every 5 students enrolled in college in the US. But I do want to note that that 3 out of 5 refers to 3 out of 5 of those students are female. Again, those close reading skills. So 3 out of 5 students are female. We've got this total group of 483 students, and we want to figure out how many guys. Any thoughts?
I think we have to make 483 divided by 5 and multiply it by 3.
Okay, so let me talk about what you're doing mathematically if you do that, because I don't just like to memorize steps. Manal is saying that if you take 3/5 of the total students, they are female. So this is the idea we're looking at here, and she mathematically knows how to accomplish this. So 3/5, that's easy. Of, just like with percents, with ratios, it's the same thing, is multiply. And then we know the total students. So 3/5 of the 483, but I'm just gonna keep note, are female, okay? So whatever answer I get from that is gonna give me my females. Okay, so now Manal, we may not have realized that's what Manal was doing, but what Manal was doing there was multiplying with fractions. She knows that numbers on the bottom are dividers, numbers on the tops are multipliers, okay? Or you could just do this in your calculator, 3/5 times 483. I'm going to do it the super lazy way, 3 divided by 5 times 483. And I get this, 289.8. So 289.8 students are female.
We subtracted from that 483.
Beautiful. Thank you, Manal. I'm so glad you said that, because so many GED students would stop right there, so proud of themselves that they remembered ratio, and just say something like 290. But yeah, Manal says those are the females. We weren't supposed to find the females. We were supposed to find the males. If we take all the students and take out the females, the rest will be male.
Yes, it's 193.2.
Good. Beautiful. And so 193.2 students are male. What do you guys think about that answer?
I think that I probably would have missed the last step on this one.
Oh, where we did the subtraction?
Yes, because
most would. It's that close reading again. So watch out. That's why I said are female. Every step of the way I carried down the fact that they are female, so I didn't forget to do that at the end. And if the math teacher has to do that, who does math 10 hours a day, how much more do you guys need to label your numbers?
Yeah.
Know what you're finding. Don't just memorize steps. But I still don't feel like this problem is done, you guys. So can I just say to you, please don't chop up people. Yeah, you're not a mathematician if you chop up people, you're a psychopath. Okay, so help me here. I'm not gonna have 193.2 male students. How many male students am I probably gonna have?
193.
Thank you, let's round that. Yeah, some things we can chop up. Pounds of potatoes, you're allowed to chop up potatoes, but please don't chop up people, you're a psychopath. Wonderful. When you look at the list of skills that are on the GED test, they actually put this one under basic math. I put it under data analysis, whatever, doesn't matter. But the skill they listed as is multi-step ratio proportions and percent problems. Multi-step. Expect them to not necessarily give you a straightforward problem, but it takes some reasoning like this. Like they told you about the females and you need to find the males. Or they told you how to find tax, but you don't need to find tax, you need to find the total after tax and discount. And guys, by the way, this is not the only way to solve this. If you would have used a proportion problem, an algebraic proportion, that's my favorite way. It would totally work. If you would use a tape diagram, like a lot of students do who are visual learners, that would have totally worked too. I just went with the way that Manal first latched onto. And by the way, guys, when I'm teaching this in my class, I teach proportion problems in 3 classes. 3 whole days I take because it's such a struggle for students. So if you feel like, oh my gosh, that's really challenging, you might want to go back to the crash course, check out those 3 classes. Next one. The table shows the age ranges of 52 students in a GED program. Which of the following could be the median age of the students? The most common student question I get is a picture of a page from the Kaplan math book. And you guys know how big that Kaplan GED book is. And I get the same question sent to me, a picture snapped of it over and over and over and over again. It is so confusing to students. And it's like this. So what are they asking me to do or to find?
The median age of the student.
Yeah, the median age of the students. And it's interesting because it doesn't say which of the following is the median age of the students. Look what it says. Could be. Could be. Weird phrasing. Which of the following could be the median age of the students? What is a median, guys? You guys already told me. Let's latch on to what we already know. What's a median?
Whatever number is in the middle, like the halfway in the middle.
Beautiful. It's the middlemost number, and we qualified it on the last problem. It's the middlemost number in an ordered set. Okay, so I got a lot of students who look at this. They say, look, it's an ordered set. They're in order. There's the middle. I'm done. They say, okay, well, we got to be in there. And then they get really confused because they're like, oh crap, there's 2 in the middle. Before we go on, I just need to say something to you. The median is the middlemost number in an ordered set of data. You have to be looking at all the items of data. It's not the middle of the table or the middle of the ranges. It's the middle of the data.
Okay.
Oh, don't forget to look for repetition. There is repetition of data on a frequency table. That is what a frequency table does. It organizes repeated data. Repeated data. So guys, I want you to imagine not that I have a table, but that I have all my students standing in a row. Can you picture that? Each one of their ages is a piece of data. All of my students standing in a row. I've got age ranges, but I've got not just one student in each range. I've got different numbers of students in each range. I need the middlemost student, not the middlemost age range. If I'm looking for the median age of the students, I need the middlemost student. So here's all my students. There's 25 of them in this age range, 13 of them in that age range, 7 in that, 5 in that, 2 in that. Where is the middlemost student?
So I was thinking you could do the number of students and the middle and then find what their age group is in.
Bingo, I like that. So the reason why everybody struggles with this is the same reason you guys are struggling. You don't know what numbers to order. So I need you to picture that all the students are standing in age order. First, you're gonna have all my teenagers. There's 25 of them. So all 25 of them are gonna be standing there first. Why are they gonna come first? Because they're the youngest. If we're finding the median of their ages, we're putting them in age order. The 25 teenagers are gonna be standing there first. Now, the problem is, of course, that I don't know their ages. It might be that these are a bunch of 16-year-olds, and then there's a 17-year-old, and then some, I don't know. But what I do know is that I have 25 teenagers all in a row. Then I have the 13 20-somethings. The median age is going to be the person standing in the middle. But obviously, guys, I don't have much time on my GED test. I do not want to list out 52 students, especially since I don't know their ages. Okay, I could draw 52 little stick figures, and I could say that, you know, the first 25 are between 16 and 19, the next 13 are between 20 and 29, the next 7 are between 30 and 39. I could draw all these little stick figures, I could label them with their possible age ranges, but all I really need is the middle. So guys, we've got 52 students in a row. Where would the middle of 52 students be?
26?
Yes, bingo. Where'd that number come from, Amy?
I don't know.
She's like, what does she want from me? Where'd that number come from, Amy?
Just 52 divided by in half.
She halved it. She said, if we got 52 students and we divide it in half, 26 will be over here and 26 will be over there. So you don't have to write out every single student and their age range. All you have to find is like the 26th student. Where would the 26th student fall?
Between 20 and 29.
Bingo. The first 25 students were all teenagers. Guess what? The 26, 27 students are going to be in this group, the 20 to 29-year-olds. I don't have to draw out all 25 of them and label them 16 to 19 to know they ain't the middle. It's the next couple of students, those in the 20 to 29 range, who are going to be the 26, 27 students who are going to be in the center. So then the correct answer here is not just the middle of the table. The correct one is the middle of the students if you listed them all out in order. The only one here that could be a median is the 21 because it's the only one that falls in this range. Okay, I realize that this is a really brutal problem. Why do you think I get sent it so much from the Kaplan? Like literally the only problem. How many thousands of problems are in the Kaplan? And they send me this one flipping problem all the time. And the one on the Kaplan has more than 1 million people in the frequency table. I dare you to draw out 1 million people. I dare you. You're not going to have time. You would have to know that the middlemost person would be the 500,000 person and go find just that person where they are. So very challenging if you don't understand a little more than just middle number. You've got to have that mathematical reasoning. Okay, if you're brutally pissed at me, I don't blame you at all. This is a ferocious concept and one that even many advanced math students wouldn't know how to tackle. Okay, I tackle it over and over and over again because it is such a challenge to most students in one of the data analysis units, and that is not this one. It's mean, median, and mode range from a frequency table. These kinds of problems only show up about 1 out of 3 times on the GED. So if you never get through this really complicated lesson, you're still okay. But I also have bad news. You will face it in college math. I tutor students with it on college math all the time.
I have the Kaplan book. I don't even know if I remember running into this.
Seeing that? I'll show it to you. That's the image that people send me all the time.
But why we divided by 2? The 52 divided by 2?
Because that would give me to the middle of the students. If I have 52 students standing in a row, the middle guys are going to be between the 26th and the 27th student. A quick way to find the middle is just to half it, divide by 2. I know that's a brutal question, and honestly, I do not feel too concerned if you are like, that's really hard, and I don't know what to do. You could totally pass your GED and never, ever look at that problem ever again. So don't let that be the thing that stops you, okay? But I also want you to have a fighting shot if you do see it to reason it out. So look at me, same exact graph, different question. And that's also like the GED. The table shows the age ranges of 52 students in a GED program. How many times more teenagers are there in the program than students in their 40s? You guys, I already had my slideshow prepared today. I was taking the last 10 minutes before class to go answer people's questions on Facebook because you know that's my favorite thing to do. And somebody posted one of these styles of questions from the science test. And I was like, oh, I forgot that in my data analysis thing. I should put it in. So I did real quick. So what are they asking me to do or to find?
How many more teenagers are in the program than 40-plus-year-olds?
So I almost agree with you, but you dropped one crucial word that would actually change how I did the problem. It doesn't say how many more, it says how many times more.
Oh.
And a lot of students wouldn't even notice that. They just gloss right over that, thinking that they're synonyms, but they are not synonyms. How many more is different from how many times more. It's still a comparison of size, but it's comparing it in a different way. So how many times more teenagers are there in the program than there are students in their 40s? So any thoughts? What numbers am I comparing? I'm obviously comparing numbers, but what numbers?
25.
Beautiful. 16 to 19 is the teenager range. There are 25 students. So we have 25 teenagers. And then we're comparing that to what? 5 students in their 40s. But now I need to figure out how many times more those teenagers are. So I'm asking you 5 times what equals the teenagers? 5 times as much. That was why I was so anal about the way you phrased that, Amy, because students who read that as how many more do subtraction. They say how many more? Well, that's 5 plus what equals 25. And they turn that around and subtract and give me a difference problem and they go 20. Okay, but how many times more? Now I need to think 5 times what is 25, or another way, of course, of thinking that, working it backwards. 25 divided by 5 is 5. This is a sticking point. So many students get this wrong, even though we consider this a simple problem in the world of math. So if you don't understand, you talk to me now. I've had so many students fight with me about this problem over the years. It won't hurt my feelings.
Yeah, I think getting to the how did you know to do the 5 times what equals 25 equation.
I want to picture this. Have you ever done long division? Think of the language we use when we're doing long division. I say things to you like, how many times does 3 go into 5? Don't I? We use that language. How many times is the signal that you're dividing? That's what division is, asking yourself how many times something goes in. So if I say how many times more teenagers are there in the program than students in their 40s, I'm saying how many times can 5 go into 25? Is anybody a visual learner and they'd like a picture?
Visualizing helps me.
Wonderful. I'm just going to draw a visual representation of this. If I have 25 teens, it's like I took that group of 5 40-year-olds and drew that 5 times. 1, 2, 3, 4, 5 times that picture to get 25 teens. Okay, so that is my visual representation of the same concept, because sometimes these are on bar charts. It didn't have to be a table. So this is data analysis, but the topic here is just interpreting tables. And again, you could be asked how many times on the math, the science, or the social studies. It's considered just a really basic data interpretation skill. But obviously it isn't basic to all students, and students very commonly make errors on it. Okay, here we go. A poll was conducted to determine if career fields traditionally dominated by one sex have shifted over the last 25 years. The results are found in the table. In 2018, the Blankenship School District employed 423 K-12 teachers. If the district follows national trends, how many of those teachers were probably male? What are they asking me to do or to find?
How many those teachers were probably male?
We have to look at the table 2018.
Sure. You want me to look in 2018? Okay. Where would you like me to look? I see a couple of places that say 2018. It says there. It says there.
The second one.
Which number would you like me to pick out?
Be teachers.
Okay, so I see K-12 teachers, and I see this, 77.3. And what does that number represent? Let's make sure we read the titles there. So that 77.3 is females as a percent of employees. So 77.3% of employees are female. That's what that heading tells me. So I know something. I know 77.3% of employees are female, but I'm supposed to figure out how many of the teachers in Blankenship were probably male. Any thoughts?
Would you put the 77.3% over 100 and then?
You sure could. I'm going to go with that same translation skill we've been using. The word of means what? I've said it twice now today.
Multiply.
Multiply. And we are going to multiply by the number of employees. So do we know the number of employees here?
420.
423. But again, Amy, I'm going to be real careful. That is the amount that are female, right? Because it said that those are the female employees. So yeah, I can totally do that to figure out the female number of employees. So let's do it. 77.3, and I'm lazy, so I know over 100 is the same as divided by 100, times 423, and I get this number, 326.979, again, are female. And notice, I'm a math teacher and I'm carrying down what my numbers mean so I don't forget a step. You better do it too if the math teacher needs to do it. Okay, now what?
423 minus 326.
Beautiful. What Amy realizes is that if we take the total employees, all of them, the 423, we take out the females, remove the female employees, the ones who are going to be left will be male.
I got 97.
96.
Cool. I got this number out of my calculator. One of you is rounding it to 96. One of you is rounding it to 97. Now, let me just say, I absolutely agree that we're not allowed to chop up people, so I do need to round it. So you're both right in that we need to round it. But what should I round it to, 96 or 97?
96.
96.
Okay.
Zero's not big enough to matter. We'll just call that good, and we'll just say about 96 are probably male.
What I did was I took off the 0.979. I just did minus 326.
Which is fine to do, but you need to round properly. Wherever you round, you should have rounded properly. So 9 is big enough to matter. So you should have taken off 327.
Okay.
That's almost a full female there. Do you see what I'm saying?
That's what I was thinking. I'm like 0.9 of a person.
Yeah, 0.987 of a person is a huge portion of a person. We're just like missing the top of her head there. Okay, so she was mostly female, not mostly male. Okay,
It's true.
so you always get funky numbers like this when it comes to real statistics because life isn't perfect. So you need to know that we're going to have to round to the nearest whole person, but you're also going to need to understand that if you had most, it was, 0.979 female, that's a whole lot of female. Okay, we should round that up to an extra female, not an extra male. I'm sure that when this goes out on the internet that we're going to have some people mad at me for deciding that there's either only male or female, but I promise you the GED math test is pretty traditional. You can assume that if they're not female, they're male. I'm just trying to get you prepped for your test. Okie dokie. So topic here is data analysis, but again, these are multi-step percent problems. Whether they give you a table or what, expect there to be a little bit going on in your percent problems. Okay, be a close reader. Okay, again, so typical of the GED science test. Let's take a look. Precipitation is defined as any product of the condensation of atmospheric water vapor that falls under gravity. Oh my goodness, what a definition. A meteorologist charted weather conditions at a certain locale each day for a year. He assigned a level to each weather condition and recorded the highest level reached each day. The results of his study are summarized in the table below, or to the right, actually. Based on the chart, what is the probability to the nearest percent that any given day in a year will not have an instance of precipitation? Whew, wordy. What are they asking me to do or to find?
The probability to the nearest percent that any given day in a year will not have an instance.
Beautiful. So we already did a probability problem earlier today, but interesting, this one requires an answer in a little bit different form. Last time we did one in a ratio, but this one asks for a different kind of probability, and they do specify this time. What kind of a probability do they ask us for? Exactly. We're going to do it in a percent form. So we are definitely looking at this as probability, but this time they want it in percents. But we can start the same way. The way we started last time when we found probability was we did the wins out of the total. Guys, we are all supposed to have the skills where we can convert percents and decimals and fractions back and forth. So even if we start that same way with finding the ratio, we could totally convert it into a percent. Okie dokie. And that's my favorite way, so that I'm only memorizing one way to do it instead of all these different ways. So what I'm going to do is I'm going to start with a ratio, and then I'll convert it to a percent using my calculator. Okie dokie. So let's do that. The win. So I'm looking for the probability that any given day in a year will not have an instance of precipitation. Okay, you guys, how many days a year do not have an instance of precipitation?
273.
The 273. Why'd you choose that number? It doesn't say over there not an instance of precipitation. What made you choose that number, Amy?
Because it says level 0, none.
None. Yeah, rain, snow, sleet, or hail. Yeah, it's in different forms, but it's all water. And so none, 273. Okay, we'll choose that. Now, it's supposed to be out of total. So what would my total be here?
Or would you add up everything? That's
okay. So it's interesting because you say add up everything and Manal said something else. Yes, I could totally find it by adding up everything. Manal, what did you say?
We are saying a given day in a year.
Beautiful. Manal knows how many days there are in a year. Manal said 365. Let's just make sure, though, that good math should always work. Whosever reasoning we're using, if we're using good reasoning, it ought to be the same. So let's just make sure. I'm going to add them all up. You know what I get? 365. So yeah, we can total up those days, or we can know, like Manal knows, that there's 365 total days in a year, and we get to the same place. So 273 days out of 365 days, I have no precipitation. Okay, now to convert this to a percent, there are multiple ways. Does anybody know how to turn this into a percent?
273 divided by 365.
Sure, that's one way to do it. I could do the implied division, and that gives me this gross number. Yada, 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 yada. Not a percent yet. It's a decimal, but I'm real close because it's super easy to go from decimals to percents. Now, what would you do?
Move the decimal twice to the right.
Absolutely. Percent means out of 100. So whether you're taking off percent signs or putting on percent signs, one quick, easy way to do it is to move the decimal 2 places. I'm going to move it 2 places to the right to put on that percent sign, and I get 74.79 about percent. ...
I did another step. It gave me this number, 74.79.
And you did it a different
just
way,
did
Manal? Is that what you're saying?
Yes, I
Okay.
just did the 263 times 100 divided by 365 is
Yeah. There's 3 common ways to do percent problems, and you're doing it the proportion way, and it totally works as well. Basically, I'm dividing first, and then when I move that decimal 2 places, I am timesing it by 100. So I'm doing the same steps you are, but in a different order. Moving the decimal 2 times over is multiplying by 100. So you probably set yours up like this, huh? And then do the multiplying and then the dividing.
This is I did.
And it's a totally legit way, but I like teaching just one way. That always works because students get, scared when there's different ways. So I like starting with that ratio. But here's the deal. Amy had to know how to convert a decimal into a percent, and not all students will. So I want to show you a calculator trick that would give you the same answer. Okay, you guys? So do me a favor. Try this in your calculator, even if you do this another way, just so we can build our calculator skills. I want you to type this fraction into your calculator. So to do that, you can do 273. N over D gives you the fraction button, and then 365. And then there's literally a convert to percent button in your calculator. It is in green, so you're going to have to push that second button first, and then you can hit that convert to percent, which is right above the closed parentheses. And you will get the exact same answer even if you don't know very much about percents. 273 over 365, right arrow, and then second, convert to percent. So you can also convert in your calculator and it'll tell you that's 74.79%. I don't care which way you do it, whichever way is easiest for you. So now that we've done it 3 different ways, I probably have everybody pissed off at me.
Aren't you supposed to round it to?
Yes, bingo, Stephen, you're right. We're not done with this problem. There's some rounding directions we haven't followed yet. Whichever way we do to find the percent, we still need to round it at the end. So Stephen, where do you think we should round it?
The 7 is 5 or above, so you make it 75%.
Beautiful. To the nearest percent means to the nearest whole percent. So I'm cutting it off at the decimal place. Yep. The 7 I'm about to throw away is big enough to matter. Let's call that 75%. In an ideal math world, I work with each one of you individually, and I do proportions with Manal because she likes proportions. And I do a ratio with Amy because she likes ratios. And with Stephen, I draw a diagram. And with Andrea, I use direct translation because she loves algebra. It don't matter which way you do it. And there's a ton of different ways to do percents, which is why it's so confusing for so many students. Like, wait, which way am I supposed to do it? Whichever way you like. We'd all get to the same answer. So it's really confusing in a class where a teacher's like, oh, you could do it this way, or this way, or this way, because you tend to mush up all the ways. So ideally, you guys are each picking your favorite way and just running with it and doing percents that way. Because I actually don't spend that much time on percents because it takes me 8 classes to teach it well, and you might get 2 of them on your test and you get a calculator anyway. This is data analysis. The topic is technically probability, but we did probability using percent. Hey, we're done. So you do not remember if you don't practice. So arise, go forth and conquer. Go practice some probability, some data analysis, some percents, all these lovely graphs that we've been doing. Make sure that you're prepared to do this yourself on the test. See you next time.
I just can't stress enough how important practice is to learning math. So don't just stop here at watching a video. Head on over to my website, the GED Math Crash Course. Link is down there in the video description. And get your practice on. Check your answers. Make sure you're ready and prepared come test day. And I just want to thank everybody who supports this ministry of helping students who've long struggled be able to finally get their GEDs and pass this test. It really is making a difference. And so thank you to those who support me on Patreon. Thank you to those of you who've bought me a coffee. And if you want to be able to do that, I've got the URLs up here on the screen. And just from the bottom of my heart, I so appreciate you supporting the work that we're doing. Happy learning.